This is an example utilizing the Dalton's law of partial pressure is in calculations. There's no specified page for this example. This is just one we're going to work together in class, and right here I'm going to work through it as well. So Dalton's law of partial pressure states that basically in a mixture of gases, the total pressure is equal to the partial pressure of gas A plus the partial pressure of gas B plus partial pressure of gas C, and so on and so forth, depending on the number of gases contained in the mixture. So in this problem, we have a mixture of several different gases, and it asks what the partial pressure of oxygen in a mixture that contains 0.7 atmospheres of nitrogen, 0.25 atmospheres of argon, and has a total pressure of 1.1 atmospheres is. So the Dalton's law that we can write for this is that our total pressure, sometimes called P total, is equal to the partial pressure of oxygen plus the partial pressure of nitrogen plus the partial pressure of argon. And so we know 3 out of these 4 variables, and we can solve for the 4th, which is oxygen. So our total pressure gives us in the problem 1.1 atmospheres. Our partial pressure of oxygen, we don't know. That's what we're looking for. Our partial pressure of nitrogen is 0.70 atm, and the partial pressure of argon is 0.25 atm. Now, as long as all of your units are the same, it doesn't really matter what unit of pressure you're in. In this case, all of my units of pressure are atmospheres. So then we can plug into our equation. 1.1 atmospheres is equal to the partial pressure of oxygen plus 0.70 atm plus 0.25 atm. And if we subtract these two, from either side, we should get that the partial pressure of oxygen is equal to 0.15 atm. So it's as simple as subtracting the numbers from one side to the other to get your final answer that the partial pressure of oxygen that makes up this total pressure mixture is 0.15 atmospheres.